Okay, in the last video, we were looking at position, velocity, and acceleration. We started with the assumption that acceleration was constant, and then we worked backwards to find velocity and then position using integration. And in that video, I mentioned that that arbitrary constant that you get when you do an integral, that arbitrary constant, you can actually figure out what it should be because it's going to be the initial velocity first, and then in the second time it's going to be the initial position, right? So that is called an initial value problem. And so I'm going to do an example of an initial value problem, which is a little more abstract, not related to free fall motion. So let's suppose that you know the derivative of a function. Let's suppose we know f prime of x equals e to the x plus 5. And we know that f of 0 equals 8. This right here, this is our initial value. Okay? And it doesn't necessarily have to be f of 0. It can be any value. Like, as long as we know f of something, that's an initial value. Now what we're going to do is find f of x. Notice, we're not talking about finding a general antiderivative any longer. Now what we're doing is we're going to find a specific antiderivative that satisfies this initial value, or like you could also call this like an initial condition. Okay, so without this piece of information, we couldn't solve this problem because there's infinitely many different antiderivatives of f prime, which could be potential f's, right? Getting from f prime to f is going to involve doing an antiderivative. But with this piece of information, specifically knowing f of 0 equals 8, we can plug in 0 for x and 8 for y and solve for that arbitrary constant, and then narrow it down from a general antiderivative to a specific antiderivative that works in this situation. So let's do it. So first of all, we know that our f of x that we're looking for is going to be an antiderivative of f prime. Okay, this is just like the whole idea here is we have the derivative, we're trying to find the original function, so we're doing the inverse of derivative, we're doing an antiderivative. And that's going to be for some specific value of that arbitrary constant. So I'm going to write for some specific constant, c. Okay. So now let's go ahead and do that antiderivative. We'll put e to the x plus 5 in for f prime, as it should be. And then that is going to give us e to the x plus 5x. So that's just using a couple of basic anti-differentiation or integration rules. But then, of course, plus c, right? So there's our problem, right? We need to figure out what particular c value we need. Well, we do that with the initial value. So now we know f of 0 equals 8, and that gives us e to the power 0 plus 5 times 0 plus the c. There's f of 0 so far. All right, f of x is this, so there's that. And then that should equal 8. And now 1 plus 0 plus c equals 8. Therefore, subtracting the 1 from both sides, c equals 7. There we go. So now we can give our final answer, which is that f of x, the function we're looking for, is e to the x plus 5x plus 7 in particular. And there we go. So that will have this derivative, and it'll have that particular function output, f of 0 equals 8. That's called an initial value problem. You can expect to see one of these on your test.